Hi and Assalamualaikum to Dr. Aizudin Supee and my fellow friend. We are from Group 2 want to present our experiment lab report which is about application of first and second law of thermodynamics. This is our team member. At the far left, we have Fakhrul Rasyid. Right next to him is Mohamad Hanis. And the third guy, which is me, Ahmad Lukman Aqil. And the far right, we have Afina Ainna. Now, we at the part of introduction. So, what is first law of thermodynamics? It is a conservation of energy principle state that energy can be neither created nor destroyed during a process. However, it can be changed from one form to another. In system, the change of internal energy caused by the heat being added or released and work being done by the system or into the system. The second law of thermodynamics states that the process must occur in a certain direction and cannot be reversed. For example, from higher temperature to the lower temperature means that energy flows spontaneously from area with greater kinetic energy to the those with lower kinetic energy. But if the flow of direction want to go from the lower temperature to the higher temperature, the outside energy must be added so that it can be performed like that. In this experiment, our objective is to apply the first and second law of thermodynamics in various processes. So, in this experiment, our materials we will be using is 150 millimeter of water, which has been heated to a temperature of 80 degrees Celsius, along with 30 millimeter of olive oil that remains at the room temperature. We will see the heat transfer between the two materials. Now we at the theory part. So the first is the energy balance. Is the net change increase or decrease in the total energy of the system during a process is equal to the difference between the total energy entering and the total energy leaving the system during that process. For the simple terms, looking at the equation below, the total energy entering minus the total energy leaving. So the value we will get is the change in the total energy of the system. So if we get zero, the value, it means that the energy being released is totally or 100% being absorbed by another material. But if this change in the total energy of the system have value, means that that amount of value have been lost to the environment. The second theory is first law of thermodynamics. The general equation is change in U equals to Q minus W. U is the internal energy, Q is heat, and W is work. To find Q, we will use the equation on the right side, which is Q equals to mCp change of T, where Cp is the specific heat capacity of the substance, m is mass, and change of T is the change of temperature between final and initial. In this experiment, we will suspect that the heat being transferred, Q loss, from hot water will be equal to the Q gain in olive oil based on the first law of thermodynamics, meaning that Q out equals to Q in. The Cp of water is 4.19 kilojoule over kg C Celsius, and the Cp of olive oil is 1.97 kilojoule kg Celsius. The last theory is about the second law of thermodynamics. This law states that the energy flows spontaneously from areas with greater kinetic energy to those with lower kinetic energy, magnifying the observed heat loss. In this experiment, the hot water will release the heat out of the system, Q out, and cold olive oil will gain the heat into the system, which is Q in, until both of the systems reach an equilibrium temperature, where there is no heat being transferred between two substances anymore.
Thank you, Lukman, for presenting the objective of our experiment, the introduction of our experiment, about the application of first and second law in thermodynamics. Okay, next we will go to the experimental setup and also the apparatus included in this experiment. First of all, we have the retorт stand with lamp, and we have the large and small beaker, we have the electronic heater, we have the electronic balance, we have the thermometer, and the substance we use for the second substance will be olive oil. We have glove, and last but not least, water. Okay, that is the experimental setup and also the apparatus that we use in experiment for the application of first and second law of thermodynamics. Next, we will go to the methodology. First of all, we know that we have the large beaker and the small beaker. So what we must do first? So we must measure and record the mass of the empty small beaker and large beaker using an electronic balance, as you can see from the picture. After we measure the mass of the empty large and small beakers, we will fill the large beaker with water until it reaches 150 milliliter. And the next step will be fill in the small beaker with olive oil until it reaches 30 ml. Okay, so we need to remember that we need to not make any parallax error by make sure the eye level are parallel to the scale of the beaker, so that we can avoid parallax error. As you can see from the picture itself, my eyes are the same level as the scale. So after that, the large beaker have been filled with water and the small beaker have been filled with olive oil. So next, we must measure again the large and small beaker that contain water and olive oil respectively. After we measure the large and small beaker that filled with water and olive oil respectively, we can get the mass of water used and also the mass of olive oil used. Next, we can go to the next part of the experiment, which is boil the large beaker with water until it reach 80 degrees Celsius. And after it reaches 80 degrees Celsius, we must measure the initial temperature of heated water, which is 80 degrees Celsius, and oil in room temperature. Okay, so when handling the thermometer, we know that we want to read the scale. So we must make sure the eye level are parallel to the scale of the thermometer to avoid parallax. And the second thing is that the tip of the thermometer inside the water and oil must not touching the bottom of the beaker, so that if it touch the bottom of the the bottom of the beaker, it will give a different temperature which could affect the experiment. Okay, next, the small beaker with olive oil will be put inside the heated boiling water, as you can see from the picture. After that, the experiment are set up as the picture shown below. Next, the thermometers are placed to record the temperatures in small and large beaker at 1 minute interval until the temperatures are equal for 3 consecutive times. And all of the data will be recorded on table 2. Okay, next we would go to the safety procedures. We know that this experiment 4, the first and second application of thermodynamics involve heating. So we must make sure that we use the proper attire, like using the electrode. Why must we use the electrode? Electrode protects the body from boiling water and prevent burns and escape temperature to the body. In case we sleep and the boiling water goes to our. Next, we have the glove. As you can see from the previous slide that I have said, we must put the olive oil to the heated water. So we must use glove to prevent any burns to the hand. Next, you must use the shoe. The same as the laptop, but it protects the feet in case any spilled water goes to the food. And we must make sure that we have clear surrounding when conducting the experiment. It is because it can avoid us from tripping. So we need to, like the Malay saying, sediakan payung sebelum hujan. So in case anything happen, like spills everywhere, we must prepare mop and cloth. A spill happen. And next, last of the safety precautions we must follow is avoid overflowing. We know that this experiment also involves filling the water and also the olive oil. So we need to fill up the water in the beaker with appropriate amount and avoid overflowing and okay, so the next part of our slide will be the raw data results, the data that we got from the experiment itself. So I will pass down to Afina.
Hi and Assalamualaikum warahmatullahi wabarakatuh. My name is Afina Ainna binti Ahmad and I will continue for the raw data and result. So these are for the table 1 and table 2, which are the table 1 is for the data for small and large beaker, and also table 2 the data for olive oil and water, which includes the heat capacity CP, mass of fluid used in kg, and also the initial temperature for both olive oil and water, which are 29 and 80 degrees Celsius respectively. So here is the data for the temperature of cold fluid, which is olive oil, and also the temperature of hot fluid, which is water. So per time, according to this experiment that we have done, so the time that we collected is 15 minutes, which the cold fluid started with the 29 degrees Celsius and the hot fluid start with the 80 degrees Celsius, and it reached equilibrium at 13th minute, which is 55 degrees Celsius. Next, to determine the result, we need to calculate the temperature change, which are delta T cold and also delta T hot, respectively, using the data from cold fluid and also the hot fluid. So for example, at T1 minute, delta T cold, T1 minus T naught, 48 plus 273.15 minus 29 plus 273.15, we get the delta T cold is 19 Kelvin. So here is where we change the degree Celsius to the Kelvin. Also same goes for the calculation at T hot. And another example, calculation for energy change. We need to find the delta Q cold and also delta Q hot by using the formula Q equals to MCP delta T. So respectively, Q gain we use the delta T cold and Q loss we use the delta T hot. So we get for the Q gain 0.96195 kJ and also Q loss negative 7.32096 kJ. Next is the example calculation for the heat transfer system. The delta Q system is equals to the delta Q gain plus delta Q loss, as in the delta Q loss in negative sign. Okay. For example, at T1, we get from previous example calculation, so 0.96197 plus with the negative 7.3216. So we get the delta Q system is negative 6.35963 kg. So here is the table 4, which includes all the data, which are the data T cold, data T hot, data Q gain and Q loss, and also the data Q system versus the time. So the standard deviation percentage here I calculated is equals to the 17.71%. Here is the graph for the temperature of fluid versus time, which the red line is the hot fluid water and the blue line is the cold fluid olive oil, and it matched at the end, which shows the equilibrium temperature reached. And the last one is the graph 2, which is the graph of heat transfer rate system, and as you can see here, the Q system in the graph is decreasing per time.
By using the result, it showed that the temperature of hot water decreased from 80 degrees Celsius every minute until the 13 minute. In the meantime, the olive oil room temperature, which is recorded at 29 degrees Celsius, increased when the oil inserted into the water filled beaker. When the olive oil comes into contact with the hot water, its temperature continues to rise gradually until the 13 minute. Our three same consecutive temperature observation of the two liquids at 13 minutes until 15 minutes indicate that the temperature of both hot olive oil and water reached equilibrium. We conclude that the experiment goal was accomplished when the temperature reached the equilibrium and there is no longer any heat transfer between the two of the liquid. The heat energy from the hot water did not disappear but rather was transferred to the olive oil until both liquids reached equilibrium temperature and remained constant after that. It means that the experiment obeyed the first law of thermodynamics. Q gain minus Q out should equal to 0, but there is some heat loss to surrounding. For example, from the data at minute 40, the Q system is negative 12.7636. It indicates heat loss to surrounding and may be the cause of the small differences between the calculated and observed values. From the graph temperature of fluid against time, we know that temperature of hot water decrease while temperature of olive oil increase. It means that heat flow is going from hot liquid to cool liquid. The second law of thermodynamics states that energy flow spontaneously from area with greater kinetic energy to those with lower kinetic energy, magnifying the observed heat loss. In conclusion, this experiment confirmed the first and second law of thermodynamics. The first law of thermodynamics says that the change in a system internal energy equals the heat introduced to the system minus the work done by the system on its surrounding. Since no work done on the system and the volume remain constant, work net is neglected and assumed that kinetic energy and potential energy equal to 0. Then Q gain minus Q out equal to 0. So the oil heat gain and the hot water's heat loss should be identical, but due to open environment, so heat loss to surrounding. Other than that, fans, air movement and moisture affect the result of the experiment. This means that the result is not 100% accurate, but the experiment still in the correct path of the objective. According to the second rule of thermodynamics, heat cannot spontaneously migrate from a cooler to a hotter place or equivalently. Heat can Heat at a given temperature cannot be entirely changed into work. In this experiment, the hot water transfers heat to the olive oil until thermal equilibrium is reached.
Okay, so thank you, Hadis, for the discussion part of our experiment. Experiment 4, the first and second law of the application of first and second law of thermodynamics. So the references that we use when we are conducting the experiment will be the Chengel, Linus, Thermodynamics and Engineering approach was done by Croft in Clear Education 2008. And we also use the internet, HTTPS, double dot, slash slash, www.studies.com. But first not to definition example definition. When we also go to the website of TPC Fund, ATU, Technical Informations, Heating System, Table of Liquids, Specific Heat, and last, the second law of thermodynamics, Physics, Libraries. Okay, that's all from us. And the application of first and second law of thermodynamics. Thank you for watching and goodbye.